Let us now solve some examples or some differential equations. Quantity 2xy minus 3x squared dx plus quantity x squared plus 2y quantity dy equal to 0. Let us determine whether the equation is exact. So the test for exactness, we have to determine the partial of m with respect to x, or rather with respect to y, and the partial of n with respect to x. For the given equation, the coefficient of dx is our m, while the coefficient of dy is our n. So for the partial of m with respect to y, we take x as a constant. So the derivative of 2y is 2 times x is 2x. 3x squared is a pure function of x, so its derivative with respect to y is 0. Now for the partial of n with respect to x squared, the derivative is 2x. 2y is a pure function of y, hence the partial derivative with respect to x is 0. And we see that the partial of m and with respect to y is equal to the partial of n with respect to x. They are equal. So therefore, we say that the equation is exact. So that means that there is a solution. Since the equation is exact, there exists a function. Since the given equation is exact, there exists f such that the differential of f is equal to m dx plus n dy. And to find that function f of xy, we take the partial integral of 2xy minus 3x squared dx. This will work equally well if we will get the partial integral of x squared plus 2y dy. So either of the two will determine the function f. So if we stick to the partial integral of m dx, we integrate 2xy with respect to x. That will give us 2x squared over 2 times y, or x squared y, minus the integral of 3x squared dx with respect to x is 3x cubed over 3, or x cubed, plus some function g of y. Because we are integrating partially with respect to x, so our constant could be a function of y. Next, we get the partial derivative of f with respect to y. So we consider x as a constant now. So any function of x is treated as a constant. We differentiate y with respect to y, which is 1 times the constant x squared. Minus x cubed is a pure function of x, so its derivative with respect to y is 0. And the derivative of g of y is g prime of y. And this is supposed to be equal to n. The partial of f with respect to y is n, the coefficient of dy. So x squared plus g prime of y is equal to n, which is x squared plus 2y. So we can see here that x squared can be cancelled. So we have g prime of y is equal to 2y. We then integrate. Integrating, we'll get g of y equal to the integral of 2y dy is 2y squared over 2, or simply y squared. So we were able to find the function g of y. Hence, our f of xy is equal to x squared y minus x cubed plus g of y, which is y squared. We shall write the general solution as x squared y minus x cubed plus y squared equal to the constant c. Let us have another example. Say we have the quantity 2xy minus tangent of y dx plus the quantity x squared minus x secant squared y quantity dy equal to 0. So we begin by determining whether the equation is exact by taking the partial of m with respect to y, and later on the partial of n with respect to x. So for 2xy, the partial derivative with respect to y is 2x, and of tangent y, or negative tangent y, that will be negative secant squared y. Next, the partial of n with respect to x. So the derivative of x squared with respect to x is 2x minus, for x secant squared y is a constant, and the derivative of x is 1, so times secant squared y. And we see that these two equations, or these two are equal. No? So since partial of m with respect to y is equal to partial of n with respect to x, therefore the equation is exact. Okay, so we are looking for the function f of xy equal to, we take the partial integral of, let us now use the coefficient, or let us now use n dy. So that will be x squared minus x secant squared y dy. So remember, we're now taking the partial integral with respect to y, so x is treated as a constant. So for x squared dy, it's just the integral of dy, which is y, times x squared. Minus, x is a constant, and the integral of secant squared y dy is of course tangent of y, plus the constant, which could be a function of x. Because we are integrating partially with respect to y, so our constant could be a function of x. Next, take the partial of f with respect to x. No? So that will be 2x y minus derivative of x is 1 times tangent y plus the derivative of g of x, which is g prime of x. And this must be equal to our m. So equate this to m, which is 2xy minus tangent y. And we can cancel 2xy as well as negative tangent y. So that leaves our g of x, our g prime of x rather, equal to 0. So that means that g of x is a constant. The integral of 0 is a constant because the derivative of a constant is 0. So our f of xy is equal to x squared y minus x tangent of y plus the constant c. And we can write the general solution as x squared y minus y, or rather minus x tangent y, equal to the constant c. And we can simplify this by factoring x. So xy minus tangent y equal to the constant c. For the next one, we try 1 plus y squared dx plus x squared y plus y dy equal to 0. Let us test the equation whether it is exact. So the partial of m with respect to y is equal to 2y, and the partial of n with respect to x is equal to 2xy. And we see that partial of m with respect to y is not equal to partial of n with respect to x. So therefore, the equation is not exact. Alright? So we pause for a while and then find out on how to solve this equation. For the coefficient of dy, take note, we can factor y. We can factor y, so 1 plus, or rather x squared plus 1 dy. And we see that the variables are separable. Alright? So we know how to find the solution of an equation where the variables are separable. So this will become dx over x squared plus 1 plus y dy over 1 plus y squared equal to 0. We can then integrate. This will be arctangent of x plus, this is of the form d over u, so 1/2 ln of 1 plus y squared equal to, let me see here, we can write here ln of c all over 2. Okay, so this will be 2 arctan of x plus ln of 1 plus y squared equal to ln of c. Okay, or 2 arctangent of x plus, let us use here negative ln of c over 2. So that when we transpose this, it becomes positive ln, and it combines with ln of 1 plus y squared, 1 plus y squared, or simply c, 1 plus y squared equal to 0. Okay? So even if the equation is not exact, we can find a way. We can find a way of finding the solution to the given differential equation. Let us have one final example. Say 2x plus y cosine of xy dx plus x cosine of xy dy equal to 0. Let us determine whether the equation is exact. So partial of m with respect to y, 2x is 0, y cosine xy is a product. So these are two functions of y. So apply the product rule, derivative of y is 1, cosine of xy plus y, derivative of cosine xy is negative sine of xy, and the derivative of xy with respect to y is x. So that will be cosine of xy minus xy sine of xy. Next, the partial of n with respect to x. So, again, there are two functions involved, x and cosine xy. So, derivative of x with respect to x is 1 times cosine of xy plus x, derivative of cosine is negative sine of xy, and the derivative of xy with respect to x is y. Cosine of xy minus xy sine of xy. So we see that the two are equal. The partial of n with respect to y is equal to partial of n with respect to x. So therefore, the equation is exact. So we define f of xy as the partial integral of 2x plus y cosine of xy quantity dx. We take the partial integral with respect to x. So the integral of 2x is 2x squared over 2 or just x squared plus y cosine xy. We are integrating with respect to x. So the derivative of xy is y. Or the differential of xy will be y dx. And we have y dx here, which is actually our du. So we just integrate cosine u du, and that will be sine of u or sine of xy plus some function g of y. Then you take the partial of f with respect to y. Derivative of x squared with respect to y is 0. Derivative of sine xy is cosine of xy, and the derivative of xy with respect to y is of course x plus g prime of y, which must be equal to n. So x cosine of xy plus g prime of y must equal n, which is x cosine of xy. So that means that g prime of y is 0 and g of y is a constant c. So the function f of xy is x squared plus sine of xy plus the constant c. And we write the general solution for the given differential equation as x squared plus sine of xy equal to the constant c.